This video is doing some more examples of solving radical equations. So again, our steps are we need to isolate the radical or the rational exponent, so the fraction exponent and whatever it's attached to. Once we've isolated that using SADMEP, then we can undo or get rid of the radical or the fractional exponent by raising the entire equation to the power of the radical, basically to the index, or to the reciprocal of the fractional exponent. And we got to remember, if we raise it to the reciprocal and your new denominator is even, then you're going to have two answers. You're going to have a plus or minus a number. Once we've gotten rid of the radical or the exponent, we're going to just solve for the variable however we need to by doing SADMEP. Then once we get our answer or answers, we have to make sure we plug them back into the original equation to make sure they work, because if they don't, we have what's called extraneous solutions, which are basically false solutions. It means if you did everything right and it doesn't work, then it's called an extraneous solution. So we're going to do 4 more examples on here. The first example is 3 plus parentheses 4 minus x raised to the 3 over 2 equals 11. So as always, I'm going to write my original problem. 3 plus parentheses 4 minus x raised to the close parentheses raised to the 3 over 2 equals 11. I need to highlight my exponent and what it's attached to, because that's what I need to get isolated first. So this is a 3 plus this parentheses, so that is added or subtracted to it, so I need to get the 3 away from it by adding or subtracting away. It's a positive 3, so I'm going to subtract the 3. So what I'm going to end up having is the parentheses 4 minus x parentheses raised to the 3 over 2 equals, we're going to do 11 minus 3, which is 8. So I'm going to write this problem up here. So I have parentheses 4 minus x raised to the 3 over 2 is equal to 8. I need to get rid of the exponent. So to get rid of the exponent, I raise it to the reciprocal of the exponent. 3 over 2 is the reciprocal of 2/3. So 2/3. Now what I have to make sure I have is on my, since I have a fraction still, I have to check, is my denominator even? My denominator is not even, so I will only have one answer for this section over here. So I'll have 4 minus x equals, we do 8 to the 2/3. So parentheses 8, close parentheses, raised to the 2/3 is equal to 4. So I'll put it equal to 4. So now I just need to solve for x. To solve for x, I need to subtract the 4 to both sides. So I get, subtract 4, so 4 minus 4 is 0. So we end up getting negative x equals 0. Well, then I just need to divide by negative 1. 0 divided by negative 1 is still equal to 0. So my answer is x equals 0. But we must check it. So I'm going to come over to the side. I'm going to check my work. So check. 3 plus parentheses 4 minus 0, close parentheses, raised to the 3 over 2 is supposed to equal to 11. So that is raised to the 3 over 2. So 3 plus parentheses 4 plus 0, close parentheses, raised to the 3 over 2 is in fact equal to 11. So that means that is good. X is in fact equal to 0. So I'm going to put a check mark on my check. Say yes, x equals to 0. On this next example, again, I'm going to write my original problem. So I have the square root of 11x plus 3 minus 2x equals 0. Now that minus 2x is outside the radical. So I'm going to highlight my radical and what's inside of it, and that's what I have to move over. Okay, that's what I have to isolate. So I actually have to add the 2x to the other side. So I end up having the square root of 11x plus 3 equals a positive 2x. Now in order to, for the next step, now that I have this isolated, the highlighted part is isolated, I need to get rid of the radical by raising it to the power of the index. So I'm going to just rewrite it up here, the square root of 11x plus 3 equals 2x. I'm just going to rewrite it up there so I have more room. I'm going to raise it to the index, the power of the index. So I'm going to raise it to, it's the square root, so I'm going to raise it to the second power. So what happens here is, again, the square root and the square are inverses of each other. That makes them go away. So we have 11x plus 3 equals. Since I'm squaring it, I won't have two answers because I'm not raising it to the fraction. So I have 2x, all of that squared. So that's 2x times 2x, which is 4x squared. Now the difference between this problem and the other ones that we've already seen is that there are actually two letter x's in the problem. We actually have an x squared, which is a quadratic. And what you want to do with quadratics is get them equal to 0 and try and factor it. So on 4x squared, we want this to stay positive. So what we'll actually do is subtract the 11x and subtract the 3 to the other side to keep it positive. So I'll put 0 equals positive 4x squared minus 11x minus 3. So that we can try and factor that. Or we can solve it using our calculator. You can get two answers. So I'll actually show, because it's a quadratic, I can actually show you how to do that in your calculator. So if we go to our calculator, turn it on, I'm going to go to my y equals. I'm going to type in 4x squared minus 11x minus 3 in my y1. Then my y2, I'm going to put my 0. I'm going to press zoom 6. And I want to find the intersection of where my parabola and my y equals 0 is crossing. So I press second, trace 5. And I find this first intersection over here. I go to this intersection. I press enter 3 times. 1, 2, 3. And I get negative 1/4. So 0.25 is negative 1/4. So I write out x equals negative 1/4. Then I want to find the second one. So I do second trace 5 again. But this time I go to the right to that location, which crossing the x-axis over here. I press enter 3 times. Enter, enter, enter. And I get x equals 3. X equals 3. But we have to check them. We have to check them. So I'm going to put my check. So I have the square root of 11 times negative 1/4 plus 3. And then minus 2 times negative 1/4 is supposed to give me 0. So this is a little bit longer in the problem, in the check. So I'm going to get out of my graph. I'm going to do the square root of 11, parentheses, negative 1 divided by 4, close parentheses, plus 3. But then I have to get out of the radical. And then I have to do minus 2 parentheses, negative 1 divided by 4, close parentheses. And this should give me 0. It does not give me 0. Now, does that mean I did it wrong? No. I did everything right, but that means that this is an extraneous solution. This is extraneous. E-X-T-R-A-N-E-O-U-S. Extraneous. So I draw an arrow to it saying it's extraneous. I cannot circle it. I got it as an answer, but it is a false solution. Okay? But that means we still have to check the 3. Now I'm going to do the same thing, and actually I can go up there and grab that, and instead of the negative 1/4, I can just type in 3. So I'm going to delete some of this part and put a 3 in there. Wherever I see the negative 1/4, I'm going to put the 3. And it should give me 0. This one does give me 0, so that means that this one does check. So we can circle that. Now, I want to show you how to do that in the older calculator, because this one, the newer calculator, you can easily see where the radical stops. The older calculators, it's a little bit harder to see. So I'm going to do it with that negative 1/4 again. So I have the square root. It opens up parentheses, so I got to be careful about that. I have 11, open parentheses, negative 1 divided by 4, close parentheses for the 1/4, plus 3. Now I need to close my radical. That's where I close this set of parentheses. See, I have 2 open, but I only have 1 closed. I have to close that one. Then I can do minus 2 parentheses, negative 1 divided by 4, close parentheses. And that one gave me 1 again. So if I do, I can't go up and grab this. I can't go up and grab it, but I can press second, enter, because that'll give me my last entry. It's the same thing. I can go over here and do the same thing by deleting and then changing that 4 to a 3. Going up here and deleting, changing that 4 to a 3. And I get that 0. The same way I did on the newer calculator. So we do have one correct answer and one false solution. Okay. All right. On example 9, again, I'm going to rewrite my original problem. I have the square root of 3x plus 13 minus 5 equals x. So I'm going to highlight my radical. Highlight my radical. Everything inside of it. Means I have to add that 5 to the other side. So to add that 5, this becomes the square root of 3x plus 13 equals, I add the 5, so it becomes x plus 5. Okay. So I'm going to rewrite that problem. So square root of 3x plus 13 equals x plus 5. I want to get rid of the square, so I need to, the square root. So I need to make sure I raise it to the whatever the power of the index, all of it. So this is the square root. I raise it to the square second power, and I raise this one to the second power as well. So on the left, we end up getting 3x plus 13 equals. Because I didn't raise it to a fraction, I know I'm only going to have that one part. I'm not going to have a plus or minus over here. But you cannot distribute the square to the x and the 5 because this is an addition in here. What this really means is x plus 5 times x plus 5. So a trick for that you can do, yes, you square the x, so it becomes x squared, but you multiply the x and 5, but then you double it because you go around the world. So x times 5 and then 5 times x together. So x times 5 and then 5 times x. That's together is 10x, a positive 10x. And then you square the 5, so that's a positive 25. So again, just like in this last problem, you have multiple different x's. Well, you have an x squared, which is a quadratic, and that means we want to try and factor it. So what we do is we want our positive x squared where it is. That means this stuff, 3x plus 13, needs to move to the other side. So when it moves to the other side, nothing will go to the x squared, so we'll have 0 equals x squared. We're going to subtract the 3x from the 10x, so that's going to be a positive 7x. Then we're going to subtract the 13 from the 25, which gives us a positive 12. Now we're going to factor this. Where it gives us, so 0 equals 2 sets of parentheses. So since it's a is 1, we know it's going to be x and x. What multiplies to 12, that will give you a 7. Okay. So 1 times 12, no. 2 times 6, no. 3 times 4. 3 times 4 does give us a 7, so it's going to be 3 and 4. It's going to be plus 3 and plus 4. Now again, if you remember, when you're solving, it's going to end up being what gives you 0. So negative 3, x equals negative 3, and x equals negative 4. So those are our two solutions. But again, you have to check. So to check, we do the square root of 3 parentheses, negative 3, close parentheses, plus 13. Then you get out of your radical, minus 5 is supposed to be equal to to your x, which is again negative 3. So that was the first one we plugged in. So let's check that. So square root of 3 parentheses, negative 3, close parentheses, plus 13, close that parenthesis for the older calculators, minus 5. Enter. It gives us a negative 3. Good. So that means that this negative 3 is a correct answer. That one checks off. So we're going to do the second one. Square root of 3 parentheses, negative 4, close parentheses, plus 13 minus the 5 is supposed to give us, again, it was the x, supposed to give us that negative 4. So I can actually go back and grab, so press second enter, and that negative 3 right here is the one that needs to change. So I just need to make that into a negative 4. And does it equal negative 4? Yes. So I can put a check mark there. That means that these are both correct answers. We do not have an extraneous solution on here. The last example is, again, I'm going to rewrite the problem as parentheses x plus 3 parentheses raised to the 1/2 minus 1 equals x. So I'm going to highlight that. Highlight the exponent with the parentheses because that's what it's attached to. I need to isolate that by adding the 1 to the other side. So I end up having parentheses x plus 3 parentheses raised to the 1/2 equals x plus 1. So very similar to what we just had up here. So I have parentheses x plus 3 parentheses raised to the 1/2 equals x plus 1. I'm just writing it up here so I have more room. Since I have a fractional exponent, I have to raise it to the reciprocal. So I raise both sides to the reciprocal of 1/2, which is a 2. And again, since I don't have a fraction exponent, I don't have to worry about putting a plus or minus in front of my answer. So I'm going to have an x plus 3 equals. Now again, this just goes right back to what I was talking about up here, the x plus 5 squared. You write it out twice. So again, I'm going to show you that trick. You square the x. You multiply the x and 1, but you do it twice. So x plus 1 and x times 1 and 1 times x. So it's x times 1 and then you double that. So 1x and 1x becomes 2x. So a positive 2x. Then you square the 1, so it's plus 1. So again, we have multiple x's, and we have a x squared, so that's quadratic. We want that equal to 0 so we can factor it. So to factor it, we have a positive x squared already. So we want to move the x plus 3 to the other side by subtracting the x and subtracting 3. So we'll have 0 equals. Nothing attaches to the x squared. We're subtracting x from 2x, so 2 minus 1 is 1, so plus 1x. And then we're subtracting 3 from the 1, so that's 1 minus 3 is negative 2. So we're going to try and factor this. We're going to have 0 equals parentheses. A is 1, so we're just going to have an x and an x. Multiply to 2 to give you 1. 1 times 2 gives you 2, and we can get a 1 from that, so it's going to be a 1 and a 2. But to get a 1, we have to do 2 minus 1. So we have a negative 1 and a positive 2. Those are your factors. But again, we have to solve. That means that 1 minus 1 gives you 0. So x equals 1, and then x equals negative 2. So again, let's go check. Check our answers. Doing our check. Put it back to the original. So parentheses, 1 plus 3, close parentheses, raised to the 1/2, minus 1 is supposed to give us 1, because it says x right here. So we have parentheses, 1 plus 3, close parentheses, raised to the, since it's the older calculator, I have to put parentheses on my fraction of a half. Then I put minus 1, and it's supposed to give me a 1. And it does. So x equals 1 does work. I'm going to do the same thing with the second answer. So I have, for the check here, I have parentheses. Again, going back here, it was x plus 3. So negative 2 plus 3, parentheses raised to the 1/2, minus 1 is supposed to give me a negative 2 because that was the x. Okay. So I'm going to do the same thing, but instead of it being a 1, I'm going to put parentheses negative 2 plus 3 close parentheses raised to the fraction, which is parentheses half, minus 1 is supposed to give me negative 2. It does not. That means that this x equals negative 2 is extraneous. This is extraneous. Extraneous right here. I'm going to draw an arrow to it. I'm not going to circle it because it's not actually a correct answer. We did everything right. We did nothing wrong, but it is an extraneous solution, so it's a false solution. So this is why it's important to check your answers, because on these 4 problems we did, we actually had 2 extraneous solutions, but the other ones worked. So again, you follow the steps of isolating the radical or the fraction exponent. Then you get rid of the radical or the exponent. Then you solve for the variable, and then you just plug it back into the original, which is why I always rewrite my original so I don't look at anything that might have been messed up from it. I always want to go back to my very original.